Welcome back to my dear friends to the Tech Civil Learning. Okay, as you know, our channel is continuously insisting with the practical educations as practical education is our motto. Hence, providing the practical education to the students is my responsibility. So my dear friends, please watch the video till end so that you can understand the concept clearly. I promised you, just give me your 20 to 30 minutes times, you will surely going to understand the concept very clearly. So I just need your 20 to 30 minutes times for this video. So without wasting times, let's start the today topics. As you know, the today topics is very important for the any competitive type of exam. So let's understand the this concept very deeply. So let's start. We'll talk about or we will study about the Hooke's law. My dear friends, Hooke's law is very relevant in the strength of materials. You, as you know, when any body in the universe, right, दुनिया में कोई भी body when it is subjected to external load, then there is a induced of stress, right? Means a body is subjected to external load, then there is a induced in stress internally. Such stress is directly proportional to strain within the elastic limit, right? Means, let me explain you. Means in this Hooke's law states that the stress is directly proportional to the strain. Okay, means there are the many materials in the universe which follow the Hooke's law up to the certain limit only, right? कुछ हद तक ये जो लॉ होता है ये फॉलो होता है आफ्टर the material changes into plasticity, then yielding stress, then many more actions. So there is nothing in the universe which does not follow the Hooke's law, right? Especially the Hooke's law gives the accuracy for the solid body. Just take an example. So the Hooke's law of the rubber means, as you know, the rubber can be easily deformed drastically. So it's very difficult to assume the Hooke's law. So before we deal with the Hooke's law, let's see some assumptions in the Hooke's law so that you can understand the concept. ये डील करने से पहले चलिए मानते हैं कि इसमें Hooke's law में क्या क्या एजप्शन लिया जाता है. सो वो पहले देखते हैं कि क्या क्या एजप्शन इसमें माना जाता है. सो चलिए एजप्शन पे चलते हैं. The first point is the chemical composition of material is constant throughout, right? Means the materials having the chemical compositions constants throughout, right? मीन्स जो भी जो मटेरियल होता है जिसका हुक्स लॉ फॉलो करता है उसमें केमिकल कंपोजिशंस होमोजेनियस होना चाहिए, ठीक है? तो मटेरियल मस्ट बी होमोजेनियस मीन्स केमिकल कंपोजिशन मस्ट बी सेम थ्रू आउट इट्स बॉडी, राइट? सो सेकेंड इज देर इज अ कंस्टेंट temperatures during the loading. Means while we examine the load versus strain diagrams, then there must be no चेंज इन टेम्परेचर टेकिंग प्लेस, ठीक है? मीन्स कि वहाँ जहाँ पे हम लोग ये एक्शन होता है मीन्स ऑकरिंग होता है वहाँ पे जो चेंज इन टेम्परेचर होता है वो डज नॉट टेक्स प्लेस. देयर इज ए कंस्टेंट टेम्परेचर्स ड्यूरिंग द लोडिंग. सो देयर इज अ नो स्ट्रेस कंसंट्रेशन, राइट? ऑन द सरफेस the surface of the body should be perfectly smooth. So let's take one a smooth body. Suppose this one is any rectangular body, right? Sorry, wait, let's imagine this is a rectangular body of having area A, right? This one's of having a cross section area A, right? But my dear friends, stress concentrations is nothing but the the locations at which the stress value is greater than the regional value. यहाँ पे जो ये बॉडी है, then of course if you study this body at the microscopic level, अगर हम इसको microscopic level पे इसको study करेंगे, then of course there will be certain molecules disturbance, right? There is no perfect smoothness. Of course there will be some what we call, there will be some irregular shape, right? Of course there will be some irregular shape. So this is nothing but the stress concentration. Stress concentration is caused by the irregular shape or irregular geometric shape of the body. So stress concentration is nothing but the stress value may be maximum at the certain locations, right? This is the body, here maybe the stress will be more where the area is less. Suppose here the area is more, and if the area of here is less, then here the stress concentration will be more. As you know, the stress is equal to P by A. So the main assumptions is that there is no stress concentration, means the body which will going to examine is perfectly smooth, right? मीन्स पूरा का पूरा स्मूथ बॉडी इसको माना जाता है, ठीक है. द मटेरियल इज डिफॉर्मेबल, मीन्स द मटेरियल इज नॉट टोटली रिजिडिटी, द मटेरियल मस्ट be deformed when subjected to external load. So these are the assumptions to be considered in the Hooke's law. So let's understand the Hooke's law now clearly. Here the Hooke says that directly proportional, means stress is directly proportional to strain, right? And strain occurs due to the stress only, means when the load is applied on the body, means of course the deformation will takes place. अगर कोई भी बॉडी में लोड लगाते हैं हम लोग, उसमें डिफॉर्मेशन होना ही है, ठीक है. सो इट मीन्स सो द स्ट्रेस मीन्स Hooke's law is nothing but the stress is directly proportional to strains. Either it may be the normal stress means proportional to normal strain, shear stress to shear strain, right? Stress to strain. So it show the linear relationship, right? Means Hooke's law show the linear relationship as it obey the straight line equation, right? Later we will discuss about. Let's see. Means this application is applicable for both tension as well as compression body. Means when the body is subjected to tensions, also this is applicable. At the same time when the body is subjected to compressions, then also this one is applicable. So here you can see that stress is proportional to strain, normal stress is proportional to normal strain, and the shear stress is proportional to shear strain. It is directly proportional to each other. So if stress is proportional to strains, then E is taken as means proportional constant, proportional constant. Then means sigma is equal to E into means small e, where E is notation as the Young's modulus. So as we know my dear friends, Young's modulus E is equal to nothing but sigma by E. So कोई भी मटेरियल का अगर योंग्स मॉडुलस ज़्यादा होता है, कोई भी मटेरियल का अगर योंग्स मॉडुलस ज़्यादा होता है, एनी मटेरियल हैविंग द मोर वैल्यू ऑफ योंग्स मॉडुलस, ऑफ कोर्स द मटेरियल विल बी more rigidity because the stress of this material is more. If the stress of the any material is more, means molecular attractions of that material is very high. आप समझिए थोड़ा. मान लीजिए कि आप स्टील है, एक स्टील रॉड है और एक रबर है. The rubber can be easily deformed because the Young's modulus value is less and the molecular attraction between is very less. Similarly, if you take the mild steel, then there is a high attraction in the molecules. So E is taken equal to, so let's see diagram. Here tau stress means shear stress is proportional to shear strain, where C indicates means Young modulus of rigidity. So modulus of rigidity C is equal to nothing but the ratio of shear stress by shear strain. So ratio of shear stress by shear strain is nothing but the modulus of rigidity. We have already discussed about the assumptions. Let's sit. My dear friends, let's plot the stress strain means Hooke's law in means stress strain diagrams. This one x y axis represent stress as stress is a function of strain, and how it is a function of strain, let's see. As you know my dear friends, stress हम लोग चलिए एक बात समझते हैं कि स्ट्रेस को ही क्यों y एक्सिस में रखा जाता है. Why stress can be plotted in y axis and the strain in x axis only. So let's see why it can be. As you know my dear friend, stress is equal to Young's modulus E into strain, where this one E can, then we can say that E is equal to FF function of E, because the value of E can be observed physically. हम लोग जो डिफॉर्मेशन होता है उसको हम लोग इजीली देख सकते हैं, बिकॉज इट कैन बी ऑब्जर्व फिजिकली, वी कैन सी बाय आवर नेक्ड आइज, राइट. सो जो ई होता है ये इसका मीन्स स्ट्रेन का फंक्शन होता है, जो स्ट्रेस होता है ये इसका फंक्शन होता है. इट इज एन means dependent. So dependent term must be taken in y axis, at the same times independent terms should be taken in x axis. So this is the reason behind it why we always take stress in y axis और strain को ही क्यों हम लोग means x axis में लेते हैं. अब यहाँ पे means this one, as I said, the Hooke's law always follow linear रिलेशन मीन्स स्ट्रेट लाइन रिलेशंस. व्हाई इट इज फॉलो स्ट्रेट लाइन रिलेशंस. आप इसको बेहतरीन से समझिए कि ये स्ट्रेट लाइन ही क्यों होते हैं. ठीक है, तो आप जानते हैं कि सिग्मा इजकल टू व्हाट ई इंटू सी. कंपेयर दिस इक्वेशंस विथ स्लोप लाइन स्ट्रेट लाइन इक्वेशन दैट वाई इजकल टू एम एक्स plus c, where this c can be assumed as 0. Then compare m e with m and this e with x. Similarly here that's why e can be called as the slope of stress strain diagrams. So this is the equation followed by straight line equation. That's why means this is the linear equation. It follow up to the certain point a. The point a is known as limit of proportionality, and the point limit of proportionality is nothing but the point up to which a material obey Hooke's law, right? A Hooke's law is nothing but the materials of having stress directly proportional to strain. So बहुत ही easy, आप आसानी भाषा समझ सकते हैं. यहाँ पे straight line ही क्यों हुआ, क्योंकि ये straight line equation को follow करता है. Compare जब हम लोग करेंगे y is equal to mx plus c, then e is means e will be slope of stress strain diagram. So here I have written that Young's modulus will be the stress of slope stress diagrams. So it is up to here the material behave linear elastic member, right? Means up to here the material behave linear, material is linear means elastic measure. Similarly, as you can see, the Young's modulus is the measure of stiffness. Stiffness nothing means deflections per unit length, means the material of having more Young's modulus having the more stiffness. So let's see the third point. Means see, you can see here in the diagram, right? If the suppose wait my dear friends, wait, आपको बेहतरीन तरीका से समझाने की कोशिश करता हूँ. मान लीजिए कि ये स्ट्रेस स्ट्रेन डायग्राम है, ठीक है, ये स्ट्रेस है, ये स्ट्रेन है, ठीक है. अगर कोई भी स्ट्रेस स्ट्रेन डायग्राम में अगर यंग्स मॉडुलस का वैल्यू ज़्यादा होगा तो ऑफ कोर्स देयर विल बी मोर strain, right? Like this type means more strains and the less deformation, right? Means deformation कितना होगा, इतना ही होगा, ठीक है. लेकिन यहाँ पे जो स्ट्रेस क्या होगा, ज़्यादा होगा. So it indicates more rigidity, means it cannot be deformed easily. चलिए समझते हैं इस पॉइंट को, लास्ट पॉइंट को, थर्ड पॉइंट को. थर्ड पॉइंट क्या बोलता है, द मीन्स modulus means Young's modulus is the value of stress which can be double the length of member. So let's understand this concept. As you know my dear friends, आप सबको पता है कि stress is equal to nothing but the Young's modulus into what, into strain, right? Strain. And as you know stress is nothing but the P by A. At the same times Young's modulus is constant, so it remains constant, and means strain is nothing but the change in length by original length. So if we will calculate this value of E, if you remove this E, then E is equal to what, it will be nothing but P by L by A into what, DL, del L, right? So this will be stress. If we replace this, means if suppose imagine आप मानिए कि del L that is change in length is equal to original length अगर हो जाएगा तो क्या हो, change in length equal to original length हो जाएगा तो क्या हो जाएगा, this can be means cancel, right? This can be cancelled. Then Young's modulus means Young's modulus equal to P by A, that is nothing but the stress. So from this it can indicate that Young's modulus is the value of stress. It is the value of stress which can be double the length of the members if the original length is double. So hope you understand this concept. उम्मीद करता हूँ आपको हुक्स लॉ अच्छे से समझ में आया हो. अगर कोई भी डाउट है हुक्स लॉ के बारे में then please comment it to the comment sections, and please means if you have any discuss, please means I have given WhatsApp link in the description box. Please join with us and solve. Means if you have any doubt then connect with me, I will solve your doubt. So let's see the another topic. Now we will discuss about the relation between or the means relation between elastic constants. My dear friends, I have already introduced, or we have already discussed about the elastic constants like Young's modulus, modulus of rigidity, bulk modulus in the previous lecture. So if you have not gone through the lecture 1, please go through, so that you can understand the concept easily. आप धीरे धीरे से समझिए, ठीक है, understand the concept slowly and steady, that makes you win, right? As we know, so let's start without wasting times. So now we'll discuss about the relation between Young's modulus and the bulk modulus. Here the Young's modulus is nothing but the stress by strain. Similarly, bulk modulus is nothing but it is the ratio of normal stress by volumetric strain, right? So bulk modulus is the ratio of normal stress to the volumetric strain. So for showing this relation, let's imagine one cube. So this is one cube as shown in figures, and this one B, C, F, G represent x axis. Similarly, this one also x axis, upward y axis, that is AB, EF, right? Similarly, this represent z axis. So normal stress is nothing. Here bulk modulus means normal stress by volumetric strain. So normal stress is nothing but the stress acting perpendicularly, right? My dear friend, understand the concept as simply as you can. जितना आसानी से हो सके उतना आसानी से कंसेप्ट को समझने की कोशिश कीजिए. सो ये एक मीन्स क्यूब है, ठीक है, उसमें जो मीन्स हर साइड से इन द सॉलिड क्यूब एवरी side is subjected to tensile stress, right? Tensile normal stress, as you can see. So if the solid cube is subjected to tensile stress in all the faces, right, in all the faces, x axis, here y axis, this one is y axis, this one is z axis, and this one is z axis, as you can see. So the direct stress is nothing but direct strain is nothing. So this one is strain. So direct strain means small e is nothing but stress by Young's modulus. Similarly, lateral strain is nothing but minus Poisson's ratio into stress by Young's modulus. As I have already introduced in the previous lectures, that Poisson's ratio Poisson's ratio is equal to lateral strain, right? Lateral strain by longitudinal or linear strains, longitudinal. So पहला वीडियो जाकर देख लीजिए, सो दैट यू कैन अंडरस्टैंड कंसेप्ट इजीली. सपोज लेट मी मीन्स टेल यू वंस अगेन. सपोज मानिए कि एक रेक्टेंगल बॉक्स है, इसको आप एक्स एक्सिस के तरफ पकड़ के इसको आप मीन्स इफ वी कैच द मीन्स इफ यू कैच द मीन्स क्यूब एंड पुल इट externally, right, means pull it means away from the centers, then there will be decrease in length in x axis. At the same times there will be, sorry my dear friends, if you pull the materials away from the its centers, मानिए कि अब इसको इस तरफ से और इस तरफ से खींचेंगे, देन क्या होगा, एक्स एक्सिस में लेंथ बड़ा हो जाएगा, एट द सेम टाइम्स वाई एक्सिस और जो जेड एक्सिस दो एक्सिस होगा उसमें कम हो जाएगा, देन देयर विल बी थिकनेस taking place, or there will be a decrease in its thickness. So here the lateral strains is nothing but the mu into Poisson's ratio into what is this, longitudinal strain. So it can be written minus mu into sigma by E. So why it is minus only, right? Here the term to why minus, because my dear friends, if you imagine if you have पेन in your hand, मानिए कि आपके हाथ में एक पेन है, उसको आप खींचिए, ठीक है, उसको आप तनकाइए, ठीक है, उसको आप जब जोर से तनकाएंगे, then there must be increase in its length, at the same time there will be decrease in its lateral lateral dimensions. So decrease in length indicates the negative sign. So let's see another here. So the net strain is in each axis will be, that is direct stress in x axis minus 2 of what we call lateral strains. So lateral strains minus mu into sigma by E. So sigma by E in x axis minus this means mu into sigma by E in y axis minus mu into sigma by E into z axis. So we will calculate here net what tensile strains. So we will subtract these ones, because suppose this one is one body, when we pull or when we apply tensile load, then there will be increase in its length, at the same time its thickness will be decreases. So here it is indicated as lateral strains minus mu into सिग्मा बाई ई माइनस म्यू इंटू सिग्मा बाई ई. सो उम्मीद करता हूँ आपको समझ में आ रहा हो. सो नेट स्ट्रेन मीन्स नेट टेंजाइल स्ट्रेन इंडिकेटेड del L by L equal to, here we will take common of sigma E, sigma by E. So here remain 1 minus, means here 1 minus 1, so minus 2, and mu means minus 2 mu. So 1 minus 2 mu. So this will be the concept. So volumetric strain. So volumetric strain is nothing but, let's take the, means as you know, the original volume of the cube is LQ. If dl will be the change in length, then dv is the change in volume. So differentiate this. So dv is equal to, if you differentiate these ones, then it become 3l square dl, right? 3l square dl, as you know, hope आपको differentiate आ रहा होगा. So dv is equal to dl square by dl. So divide these terms with, means original volume, that is v. So dv divide by v dv, and the original volume is nothing but the L cube. So if L cube, this L square and this one L cube cancel, then dv by v is equal to 3 dl by L. So if you substitute that del L by E is nothing but change in length, original length is nothing but strain. So strain is nothing but stress by Young's modulus. So that's why we substitute, that is means del L by L is equal to sigma by E, right, and 1 minus 2 mu. Due to the shear stress, or due to the shear force, there is the cube is distorts to L m bar s bar or s dash to t. So stress means strain can be written as this one's here, the angle strain can be written as that the s changes to s bar by st. This one is st, right. So similarly, as you also know, the means modulus of rigidity is nothing but the shear stress by shear strain. So this one, so if the here the strain is equal to ss bar by st, here tau by modulus of rigidity. So this equation can be equated or compared, then can be written as ss t by tau by, means tau by c. So consider this as equation 1. Similarly, on the diagonal L means L s bar, draw perpendicular Sn from S. Here you can see, let's see the in the figure, these ones L to S bar, this is the diagonals subjected to tensile stress. So we'll draw Sn perpendicular from S. यहाँ से हम लोग S से एक perpendicular line draw करेंगे, ठीक है, L S bar पे. So we can write that the diagonal strain is equal to ns bar by n, means L n. This is so because strain is nothing but the change in length by original length. So here ns is nothing but the change in diagonal, right, means initially it was L, means L s, so it was changes to L s bar. So L, so it means ns is the change in length, and the full length is means L n. So you can see from the figure that ns is change in diagonal by original diagonal. So we can also write it as ns by ls. So we'll substitute n L n to ls. So from the means a triangle S n s, from the above S n s, ns can be written as ss cos 45, right, where we have 90 degree and the means angle theta. So ns can be written as ss cos 45 degree in this triangle, right, means let's see, from this triangle means S n, and with this one is perpendicular, means 90 degree. So we can write it as, means if you need to write, then ns, this one n and s, ns bar is means ss cos 45 degree, we can write it as. So we can see, we can write it as L s bar t, that is equal, means assume to be equal to L s t, since s s is very small, means the distortion taken by the shear stress is very small. So this angle can be equal to this angle. So from the triangle LST, from triangle LST, cos theta is equal to b by s, that is st by ls, as you can see from the means figure above which is given. So if you need to calculate ls, then it is equal to st root under 2. So just substitute ls is equal to st root under 2 and substitute this ls value in this equation 2, means substituting this value, then the diagonal strain will be equal to SS bar by root under 2 ST into root 2. So finally we can write SS bar by 2 ST. So if we substitute all these, that means diagonal strain is also equal to tau by 2C, and that is normal stress by 2C. So where n is normal stress, so the net stress can be written as, through the diagonals, n sigma n by n is equal to sigma n by m into E. So here if you take sigma n by m common, then 1 plus 1 by m, this is m, 1 by m. So compare this equation third and fourth, compare this equation with the third equation, then we can write it as sigma n by 2C is equal to sigma n by E, 1 means 1 plus 1 by m. So 1 plus 1 by m is nothing but the mu. So we can write, means the relation between Young's modulus and bond radius of rigidity is equal to E is equal to 2C into 1 plus mu. So this is the relation between elastic constant. Hope you have understood the concept. So what I try to convince you. उम्मीद करता हूँ कि आपको अभी तक समझ में आया हो. अगर फिर भी आपको कोई डाउट है, then don't hesitate to ask me the doubts. Please comment it, means comment me in the comment box so that I can solve your doubts. So let's see the stress strain diagram. My dear friends, stress strain diagram is very important for any type of competitive exam or for the university levels. ठीक है, यूनिवर्सिटी लेवल्स का भी पॉइंट्स है और कोई competitive exam का भी पॉइंट्स है, बहुत ही important होता है. So let's see stress strain diagram for the ductile and for the brittle material. As you know, stress strain diagram is nothing but the graphical representations of, means stress versus strains, means when the load is applied in any sub body, means then there will be deformation taking place, means as the load increases, the deformation, the quantity, means the percentage of deformation is also increases. So the means stress strain diagram is the graphical way to show the reaction of materials when the load is applied, means what will be the reaction of material, whether the how much deformation will takes place, जब हम लोग लोड लगाएंगे तो उस पर कितना डिफॉर्मेशन होगा, क्या क्या होगा, उस सभी को स्टडी करने के लिए, ठीक है, विल draw the stress strain diagram. So stress strain diagram considered from the data obtained in any mechanical test. As you know, my dear friends, as a civil engineers, we have conducted many tests, like means we have conducted tensile strength test in the UTM machines. So this is the mechanical test from, means stress strain diagram can be considered from the mechanical test where the load is applied to the material continuously and the measurement of stress and strain are made. So let's, without wasting time, let's draw the stress strain diagram for ductile material. First need to understand is what is ductile material. Ductile material is nothing but the material which gives large degree of plastic deformations before fractures. मान लीजिए कि एक मतलब रॉड है, ठीक है, जब रॉड को इसको टेंजाइल मीन्स स्ट्रेंथ लगा के इसको जब मीन्स टेंजाइल स्ट्रेंथ लगाएंगे, बाहर की तरफ खींचेंगे, then it must give means large number of plastic deformation, means this material cannot easily crack or means fail, means it gives large means degree of plastic deformation, means ये पहले तनकेगा, ठीक है, means बहुत ज़्यादा तनकेगा, means before failure it show lots of criteria. So this is nothing but the ductile materials, and the ductile materials can be drawn into thin wire by hammering. देखिए हैमर से इसको thin wire में भी हम लोग चेंज कर सकते हैं. अगर इसको टेक्निकली समझा जाए तो कोई भी जो परसेंटेज ऑफ इलोंगेशन है अगर ग्रेटर देन 15% है, देन द मटेरियल इज सेड टू बी कम्प्लीटली डक्टाइल मटेरियल. And you know the percentage of elongation is nothing but the means length of length of specimen at fracture minus means original length by original length into 100%, means any materials means how much percentage is deformed, means when the material is subject to either the compressive load or the tensile loads, then how much percentage material can deform. So the percentage of deformation is greater than 15%, then the material is completely ductile. If it is less than 5% and the means if it is less than 15% and greater than 5%, then it is known as intermediate ductile. Here I have noted the means percentage, means what is percentage of elongations. So let's hope you means उम्मीद करता हूँ कि आपको ductile material समझ में आया होगा क्या है. जैसे मतलब मान लीजिए कि वायर जो है means mild steel है, these are the ductile materials, means it cannot be easily crack or means break. So means mild steel is the best example of ductile material. So let's plot the stress versus strain diagram. So let's imagine one specimen of having large diameter at 2 end, right, means दोनों साइड पे means बड़ा diameter है, and of having the small diameter at the centers, means this is nothing but the means gauge length, and this one is provided so that in the UTM machine, this experiment is conducted in UTM machine, so that the means UTM jaw can be easily fitted into this to means outer diameter, and means it gives the tensile strength these specimens. When the tensile strength is applied on this material, the material means start deforming, right, and its diameter starts decreasing and its length start increasing, right, because when any material is subjected to tensile load, then that means its deformation means gauge length start increasing, and as you know that the deformation we can see easily. So my dear friends, as you know, the stress is the function of strain. So if the means load value increases, then area decreases. कैसे डिक्रीज होगा, मैं पहले भी बोला हूँ कि अगर ये मतलब कोई रेक्टेंगुलर मीन्स रॉड है, जब इसको बाहर की तरफ खींचेंगे तो यहाँ पे तो लोड इंक्रीज करना पड़ेगा, जब लोड इंक्रीज करना तो इसका क्या होगा, एरिया कम होगा, ठीक है, इसका जो एरिया है वो कम होगा. सो लोड इंक्रीज ग्रेजुअली. सो लेट्स सी द स्ट्रेस स्ट्रेन डायग्राम. I have already introduced why the strain is taken in x-axis and why the stress is taken in y-axis. See, any material which follow means Hooke's law, right, means up to the point A, a material flow Hooke's law. So it is nothing but the limit of proportionality, means a point up to which a material flow Hooke's law. This flow means y is equal to or E is equal to Young's modulus into strain. So up to here it is a straight line, right. When the load increases continuously, means when the stress increases continuously, then materials changes up to B, right, means here the material loses its elastic property. B तक material आएगा, ठीक है, B के बाद material क्या होगा, elastic property lose कर देगा, right. B is nothing but the elastic limit, means the material which behave elastically up to the point B. After the point B, when the load is applied, the material cannot regain its shape again. So B again, if we applied the load, then it changes to C. C is nothing but the upper yielding point, and yielding point is nothing but the point at which material loses its elastic properties and changes into where, plastic property, right. The point C, material completely loses its means elastic property. Elastic property यहाँ means elastic property nothing but the means once the load is removed, the body can regain its original, or body can means regain its original shape and size. So yield means point is nothing but the point at which material loses its elastic property. So again it means come means stress automatically decreases. Now आप लोग का मन में क्वेश्चन आ रहा होगा कि यहाँ तक तो ठीक है भाई, कि मतलब लोड इंक्रीज हो रहा था तो ऊपर की तरफ जा रहा था, अचानक से ये नीचे कर्व कैसे गिर गया, राइट. मीन्स इफ यू रियली नीड टू अंडरस्टैंड दिस, लेट्स मी ट्राई टू अंडरस्टैंड यू, लेट मी ट्राई. लेट्स अंडरस्टैंड दिस कंसेप्ट व्हाई C to D means decreases in means stress. Suppose imagine this one is a rectangular means sections. If you cut this section, right, if you cut this section, then this one is P, and there must be a resisting force F, right. There must be a resisting force F. My dear friends, this F is nothing but the molecular attraction force, means internal molecular means attraction force. As we know, means हम लोग को पता है कि when means before yielding होने से पहले that P is equal to F, means this one is before yielding, but once the yielding takes place, then there must be means molecular attraction of this one must be decreases, right. means जो इसका molecular attraction होगा वो कम हो जाएगा. means yielding का बाद क्या होगा, ये force का जो F का value है वो कम हो जाएगा. means F is less than P, right. जो F का वैल्यू होगा वो कम हो जाएगा. क्यों कम हो जाएगा, क्योंकि जो मोलिकुलर अट्रैक्शंस जो उस सेक्शन में था वो कम हो जाएगा. जब मोलिकुलर अट्रैक्शन कम हो जाएगा, देन ऑफ कोर्स इसका जो रेसिस्टिंग फोर्स होगा वो कम हो जाएगा. तो जब हम लोग को पता है जब ये फोर्स कम हो जाएगा, देन फोर्स इज डायरेक्टली प्रोपोर्शनल टू व्हाट, स्ट्रेन. तो जब ये फोर्स ही कम हो जाएगा आफ्टर यील्डिंग, देन स्ट्रेस भी कम हो जाएगा. इसीलिए यहाँ पे भी स्ट्रेस नीचे की तरफ आया. एंड so that's why this curves means comes in downwards. as the molecular attraction of the force decreases after the yielding, because means yielding is the point at which means the material loses its elastic behavior. So here up to means some point the some material will follow uniform criteria. So after this point again it increases. Now here again the questions comes in mind, why again increases. My dear friends, as you know the molecular of here is means the molecular of this section is disturbance. Suppose मानिए कि आप एक क्लास में, ठीक है, suppose imagine a classrooms, right, that means we all students are molecules, right. If we students, if some of students comes in the gate and stock there, right, मीन्स कुछ स्टूडेंट्स क्या करेगा, गेट पे आके वहाँ पे स्टॉक हो जाएगा, ऑलरेडी मोलिकुलर डिस्टर्ब है, ठीक है, इसीलिए नीचे की तरफ कर पाया। लेकिन मानिए कि क्लास में मीन्स कुछ स्टूडेंट आके गेट को ब्लॉक कर देते, देन अगर जब पूरा का पूरा विद्यार्थी क्लास से बाहर जाने की कोशिश करेगा, इफ़ ऑल द मास ऑफ द स्टूडेंट्स ट्राई टू कम आउट फ्रॉम द क्लासेस and if the some of the students have blocked or stacked in the gate, then it's very difficult to come out. Means again there exists, means there existence of large number of internal resistance, means large number of molecules, means one molecule stacks another, means one student stack another, one student stack another, so there is increase in what, load. So that's why from here it automatically goes upward, right. उम्मीद करता हूँ कि समझ में आ रहा है। ऑलरेडी हम लोग को मोलिकुलर डिस्टर्बेंस हो चुका था, मोलिकुलर डिस्टर्बेंस होने के कारण, ठीक है, कर्व नीचे की तरफ आया था। लेकिन मान लीजिए अब जब मोलिकुलर्स फिर इसमें लोड लगाएंगे तो सब मोलिकुलर्स का होगा एक जगह पे स्टैक हो जाएगा, ठीक है। सपोज क्लासरूम का गेट पे स्टैक हो जाएगा, जब हम लोग निकलेंगे मतलब मास स्टूडेंट्स ट्राई टू कम आउट, देन ऑफ कोर्स इट्स वेरी डिफिकल्ट टू कम आउट। सो दैट्स व्हाई द कर्व मूव अप and after that E is nothing but the ultimate stress, means maximum strength. After that fractures takes place. So this is the concept of the stress strain diagram for mild steel. So it follow the Hooke's law up to the certain point, that is up to the point A, and the permanent plastic deformation is taken as the failure criteria. In the mild steel, permanent plastic deformation is taken as the means failure criteria, and it is very weak in what, shear stress. So let's talk about the means the brittle material. Brittle material is nothing but it gives the low degree of deformation, that is plastic कोई भी मान लीजिए concrete is a perfect example of means brittle materials. Means concrete, when you applied the tensile load, the concrete does not give any deformation because it is very weak in tensiles. So there is a low degree of plastic deformations before fractures. So means that if there is a low degree of deformation, then of course there will be the low means reduction in cross section area. जब कम ही मतलब कोई भी मटेरियल अगर कम डिफॉर्म होगा, देन उसके क्रॉस सेक्शन एरिया ऑफ कोर्स कम डिफॉर्म ही होगा, एंड इट्स वेरी डिफिकल्ट टू ड्रॉ इनटू द थिन वायर बिकॉज इट कैन ब्रेक इजीली. एंड इफ यू कैन अंडरस्टैंड द मीन्स इफ द परसेंटेज ऑफ इलोंगेशन इज लेस देन 5%, 5% से कम है इलोंगेशन का कैपेसिटी, देन इट इज ब्रिटल मटेरियल. सो लेट्स सी द स्ट्रेस मीन्स स्ट्रेन इन x axis, stress in y axis up to point A, it follow what, limit of proportionality, ठीक है. B means elastic limit up to the point B, a material is subjected to elastic. After this one it changes into plasticity, like this point is known as ultimate points, and at the point fracture takes place. In this one, so no yielding is taking place because it can fractures easily. So my dear friends, we should always design any structures, means or we should always use the ductile materials for designing any structures. हम लोग जब भी कोई भी स्ट्रक्चर डिजाइन करेंगे, then you means try to utilize your ductile material so that it gives you it means ये आपको पहले बता देगा कि कब फेल होना है. means it does not fail suddenly, but the brittle material can fail suddenly. So let's see some numerical based on the इलास्टिक कंस्टेंट. चलिए कुछ न्यूमेरिकल देखते हैं. मीन्स इसका अगर अच्छा खासा कंसेप्ट हो गया होगा इलास्टिक कंस्टेंट में, रिलेशन बिटवीन इलास्टिक कंस्टेंट में, देन माय डियर फ्रेंड्स यू कैन इजीली सॉल्व द न्यूमेरिकल. सो हेयर इज नथिंग, एक मीन्स कंक्रीट का सिलेंडर है, ठीक है. देयर इज वन कंक्रीट सिलेंडर्स जिसका डायमीटर 150 एंड द लेंथ ऑफ दिस वन इज 300. सपोज दिस वन इज जस्ट मीन्स रफ डायग्राम, अ कंक्रीट cylinders, its diameter is 150 and its length is 300, right, and it is subjected to axially compressive loads of 240 kilonewtons, which result in increase in diameter. आपको पता है जब ऐसे मतलब ऊपर से इसको कंप्रेसिव लोड लगाएंगे देन ये क्या होगा, इसका लेटरल डायमेंशन इंक्रीज हो जाएगा, राइट. ये साइड इंक्रीज होगा तो ये साइड क्या होगा, डिक्रीज हो जाएगा, बिकॉज कंप्रेसिव लोड के कारण से डिक्रीज हो जाएगा लेकिन ये इंक्रीज हो जाएगा. सो द इंक्रीज इन डायमीटर इज 0.127 mm, मीन्स इतना इंक्रीज हो गया, एंड द डिक्रीज इन लेंथ इज 0.28. सो कंप्यूट द वैल्यू ऑफ पॉइजन्स रेशियो दैट यू, or it may be equal to 1 by m, and the modulus of elasticity. So any numerical, first note down what is given in the question. So diameter is given, length of cylinder is given, increase in diameter, decrease in length is given, axial. So it's very easy to calculate. First calculate longitudinal strains, that is means x axis, right, means longitudinal strain is nothing but the this with this, means then calculate longitudinal strain, that is change in length by original length. Here the change in length is already given, original length is given, then it comes. Similarly lateral strains, when this one is subject to compressive strain, then there must be increase in its external diameter, or means its diameter. So change in diameter by this one, it came. So the Poisson's ratio is nothing but the ultimate means lateral strain by longitudinal. So Poisson's ratio come. Similarly modulus of rigidity is stress by strain, where stress you can calculate P by A, change in length by A. So we can easily find the modulus of rigid means modulus of elasticity. So let's see the next numerical. Here in this questions for any materials, right, suppose मानिए आपके पास कोई मटेरियल है जिसका योंग्स मॉडुलस का वैल्यू है मीन्स 110 giga Newton per meter square and shear stress modulus is 42 giga Newton per meter square. Then we have to calculate the bulk modulus and the lateral contractions, means lateral decrease in its lateral dimensions of the round bar, its diameter is given and the length is given, and it the means change in length is given. So first of all what I have told you, please note down what is given in the questions. So everything I have noted down, and as you know the relation between Young's modulus and the modulus of rigidity is equal to 2c 1 plus mu. Just substitute the value of here and we will calculate the value of mu. Here E is already given, C is given, so you can easily calculate mu. So mu is equal to 0.31. If the mu value came, then you can easily calculate lateral strains, that is means lateral longitudinal strains means change in length by L length, a lateral strain is equal to means as we know Poisson's ratio is equal to lateral strain, that is change in sorry guys, wait, that is lateral means Poisson's ratio is equal to lateral diameter by longitudinal, right. So lateral, this one is equal to this into this. So this one means mu value already we have calculated 0.30 into 0.0040. So lateral strains, that is lateral contraction, is 0.0035. So it's very easy to calculate all those types of numerical. So let's see. So this means these are the data which are means which are taken from the tensile strength test. These are the observations which are means taken from the tensile strength test in UTM machines. So here the diameter of bar is given 30 mm, tensile 54, gauge length as I have told you, gauge length is 30 mm, extension of bar takes place 0.12 mm, the change in diameter is this one due to the tensile load. Find the Poisson's ratio, it is very easy. Similarly all three modulus, that is Young's modulus, modulus of rigidity, and the means bulk modulus. So if you know the relation between them, you can easily calculate. So Poisson's ratio can calculate mu. So first stress will P by S, the stress value is 76.4 mega Newton per meter square. If it is means 7000 means 76,394 kilonewton, if you change into mega Newton, then means divide by 6 means 10 to the power 6. So lateral strain is equal to change in length by original length. So the lateral strain longitudinal. So you can easily calculate Poisson's ratio. So from the if the Poisson's ratio came, then means Young's modulus stress by strain. Stress we have already calculated, strain already it is given in the questions. As you can see strain is means 3.73 into 10 to the power 0. So it is nothing but the means linear strain. So 3.73 into 10 to the power 4, it is means longitudinal strain. So substitute. So Young's modulus came from this relation is equal to 2c 1 plus 1 by mu 1 by m. 1 by m is nothing but mu. From here we can easily calculate c value. Similarly from this relation Young's modulus and means bulk modulus we can easily calculate k. So finally I would like to say that this one is very easy concept and very important for any means competitive type of exams. Just understand the concept practically so that you can understand the concept. उम्मीद करता हूँ कि आपको समझ में आया होगा. अगर if you really like my video, please subscribe my channel and share it to your friends so that they can understand. And please आप अपना ध्यान रखें और means enjoy your study. Thank you for watching my video.